Yes, good morning guys to all of you. So I welcome you all on this wonderful platform that is BYJU'S Exam Prep. And guys, this is the very first episode in the concept capsule series. This is common for both mechanical and civil branches. Actually today I am here with a wonderful concept capsule on the topic of centripetal force versus centrifugal force. I know this kind of discussion you have already seen in the mechanics when you were in 11th class, you were preparing for IIT JEE. But my dear, this is also important for GATE examination because engineering mechanics is as a subject present in GATE syllabus, ESC syllabus as well. And not only that, if you are going for the examination like BARC, ISRO, DRDO and other examinations, there also such kind of concepts are becoming very important. And also my dear, for interview purpose, this is a very important concept, interesting one. And the most important reason, there are many subjects where you would be using this. Like for civil engineering people, when you would be going for transportation part, you are going to use the concept of centripetal and centrifugal forces. For mechanical engineers, when they would be going in the theory of machines, in governor part, in balancing part, in velocity acceleration analysis, they would be also using this concept. Okay. So that is the reason why I have taken this topic for the very first concept capsule. So very first episode in this concept capsule series. So guys, we are starting the session now, and this is a very important thing. So we would be having the discussion on centripetal force versus centrifugal force. This is the thing where many students have doubts also. So I will try to take care of all the doubts what you can have in this topic. So let us start the session now. So guys, this is some detail about me. I am having 10+ years of experience in this field of GATE and ESC. And my dear, I have written many research and review paper. These are my areas of interest. And this topic is related to engineering mechanics and going to be useful for theory of machines as well as transportation for civil peoples. So my dear, first of all, we need to understand what is centripetal force actually. So my dear, when we are talking about centripetal force, many people have misconception that it is a fundamental type of force, like we study spring force is there, gravitational force is there, normal reaction is there, friction force is there. So my dear, first thing I would like to say about this, it is not at all a kind of fundamental force. Okay. So what is it actually? So my dear, here you can see one example that when we are going to have circular motion, you can see here one body is moving in circular motion. Now my dear, circular motion you can have of two types. One is with uniform angular velocity where omega is going to be constant, and you can also have another with omega is going to be variable. So my dear, whatever, if omega is constant or variable, if you have any body which is having a circular motion, let us say this is the body which is rotating in the circular motion with a velocity v. So my dear, you know, at this instant if velocity is v, which is given as r into omega. If we are having omega is constant, then my dear, v will also be constant. But my dear, if you see, this is the center, this is the radius. At this location, when the body will reach, the velocity will be like this because velocity is perpendicular to the radius. At this location, this would be the velocity direction. At this location, this would be the velocity direction. You can see, my dear, if you are taking uniform circular motion, then also the magnitude may be constant. V is equals to r omega, v is equals to r omega, because omega is constant in uniform circular motion. But my dear, if you see carefully, every time the direction of velocity is changing. Here direction of velocity is this, here this, here this, here this. So my dear, you know, velocity is a vector quantity which is defined with the help of both magnitude and direction. And if direction changes with the time, if direction is going to change with the time, then my dear, obviously acceleration will be existing. Then my dear, for sure acceleration will be existing. And my dear, the acceleration which is responsible for this change of direction of velocity is given the name of centripetal acceleration. This is given the name of centripetal acceleration. So when we are talking about centripetal acceleration, this is the acceleration which is responsible for change of direction of velocity. So my dear, if that is responsible for change of direction of velocity, it simply means that if velocity is going to vary in direction, then centripetal acceleration would be there. Yes or no? It means, my dear, this is the acceleration which is responsible for change of direction of velocity. I would be saying the inverse statement. Actual statement is, my dear, if centripetal acceleration would be there, then only the direction of velocity would be changing. And once the velocity direction would be changing, then only you can call it as a circular motion. So my dear, any body can have this circular motion only if centripetal acceleration is there, and this centripetal acceleration always acts towards the center of rotation. It always acts towards the center of rotation, and my dear, its magnitude is given as omega square r. Now my dear, if you are saying that this is the acceleration, so acceleration is coming because some force is going to be applied. Without forces, acceleration cannot be there, because force is mass into acceleration. So it means, my dear, the force which is responsible for this circular motion is given the name of centripetal force. I feel you got that. If we would be providing centripetal force to any body, then that body would be in the circular motion. So centripetal force is not something which would be coming into picture if you would be giving circular motion to someone. No, circular motion is the result of centripetal force. If you give this body centripetal force, this body will come in circular motion. So circular motion is the result and centripetal force is the cause. So cause and effect you must understand. So centripetal force is cause and circular motion is the result. So my dear, that centripetal force is not a fundamental type of force. Any kind of force can act as centripetal force, and I would be giving you many examples related to that. If you take this case, we are having a thread, and with this thread we are having a ball like this or a stone like this. So my dear, when you are taking a thread and you are trying to rotate this thread like that, so when you are doing that, you are going to provide tension in the thread, and my dear, that tension is acting like a centripetal force, because if this body is coming in the rotation, in the circular motion, so for this circular motion the requirement is centripetal force, and you are providing the centripetal force in the terms of tension. So my dear, here tension would be acting as centripetal force, which is m into centripetal acceleration, which is m omega square r. So my dear, centripetal force can be provided by tension, can be provided by gravitational force, can be provided by any other kind of force. So centripetal force is the cause. If it is present, it would be creating the circular motion. So my dear, that can be provided in any terms. Means centripetal force is not like I would be saying that apply the centrifugal force. These two bodies are subjected to centripetal force. No, actually there would be some force which would be acting like centripetal force. Like here, tension is providing the centripetal force. Okay. So my dear, if we see some other examples, my dear, other than that, if we take another example, I am having a lot of examples for you guys. Like if you see the case of simple pendulum. Now my dear, if you have the simple pendulum, you know that this is the thread and this is having a ball. So my dear, you know that this ball would be having a weight component downward and a tension component here. And you know, if this angle is going to be theta, you can find out tension with the help of mg. Obviously you can find out that. So my dear, you know this component would be mg cos theta. This is going to be mg cos theta and this is going to be mg sin theta. So with that you can write tension is nothing but mg cos theta. So my dear, this tension which you are saying as mg cos theta, my dear, this is acting like a centripetal force because this ball is in partial circular motion. So if this ball is in partial circular motion, it means its velocity direction is changing at every instant. So there should be a centripetal force. So from where it would be coming? It can come only from one place, that is the tension. So a tension would be providing the necessary centripetal force. Okay. Let us see the next case, my dear. Let us see the next case. In the next case, we have conical pendulum. And my dear, if we see the conical pendulum, you know this is the cone in which the ball is going to rotate. So you can see here you are having a component of weight mg. Here you have a tension component st. So my dear, if you would be looking at this angle would be coming out to be theta. So this component would be t cos theta and this component would be t sine theta. So my dear, you can see that here this ball is rotating in this because this is becoming the cone. So in circular motion, this ball is rotating in this circular motion. So if any body is rotating in circular motion, its direction of velocity changing at every instant. So there should be some centripetal acceleration or force. So from where that centripetal force would be coming in this case, my dear, it is coming from this t sine theta component. So this would be providing the necessary centripetal force. So my dear, likewise, it can be any force which would be providing the component required for circular motion. If that component would not be providing Fc, the body cannot be in circular motion. So my dear, one more example I would be having in front of you is Earth is rotating about the sun, around the sun. You know that Earth is also rotating about its own axis. We are not talking about that. I am talking about that Earth is rotating around the sun. So my dear, when you are having a sun, around the sun, Earth is rotating. So if Earth is rotating around the sun, definitely my dear, it is in circular motion. It is in circular motion. So if it is in circular motion, it must be having a centripetal force. Otherwise, circular motion is not possible. So my dear, between sun and earth, there is a gravitational force which is given as G m upon r square. And that gravitational force is going to be attractive one. So this gravitational force would be providing the necessary centripetal force for the rotation or circular motion of the earth around the sun. So my dear, centripetal force can be provided by any component of force. Any component of force can provide the centripetal force. So my dear, next we will have one more example. Like when your car is going through a turn. Let us say you are having a turn like this and your car is moving. So my dear, when your car is moving, then my dear, your car would be having 4 wheels and those wheels are coming in contact with the earth. And you know this, it is going to be a pure rolling motion between wheels and the road. In pure rolling motion, my dear, it is considered as nearly equals to the static friction. So my dear, static friction, you know that it is said to be a variable force which can change its magnitude and direction based on the requirement. So my dear, when this car is going with the constant velocity, then my dear, friction would be coming in the wheels and that friction would be providing the necessary centripetal force here. So my dear, centripetal force here is provided by the static friction coming between the road and the wheels. So my dear, you have seen many times that whenever the turns are there, there are chances of accidents are more. So when accident occurs when, my dear, this circular motion is going to break. Because when a car is going to take a turn, it is going to be a circular motion. And that circular motion requires a centripetal force. And my dear, that friction is always limited because static friction has a maximum value of μs times of n. And it is going to be like 0 to μs times of n. So my dear, if that is the limit of static friction, if the requirement, you know, centripetal force is m omega square r, or you can also write it as mv square upon r. So my dear, if you would be running at higher velocities, you would be requiring more centripetal force, and if friction is unable to provide that centripetal force, circular motion is going to break. And if circular motion is going to break, my dear, it simply means it is going to be result in an accident. So accident will happen, and my dear, that is why it is written in the, when you are going to the hilly areas, that आगे तीव्र मोड़ है, कृपया गाड़ी धीरे चलाएं, slow down. Okay, it is written. Why? Because तीव्र mode means you are having a turn, and that turn would be requiring, if you want centripetal force, more velocity, more force requirement. If friction is unable to give that, my dear, you may meet to an accident. And my dear, even in the hilly areas, there are chances of that ice and all. In that case, friction reduces, so friction's capacity also reduces to provide the centripetal force. So in the hilly areas, we are also going for the concept of banking of roads. So my dear, when you are going for banking of roads, what happened with that? So my dear, obviously, you know, when your car was running on this surface, then my dear, if it was going to be like this, you know that centripetal force was coming from the friction. But now if you have made the road like this elevated road, then my dear, your car would become like this. Now what is going to happen, my dear? Now one thing I would like to say, that here normal reaction would be like this and friction is going to be like this. So my dear, this friction would be providing a component towards center and normal reaction would also be providing a component towards center. So these two together, static friction plus normal reaction, both would be providing component which will try to provide you the centripetal force. So that is why banking of road is done, and you have studied that concept in the engineering mechanics. So guys, this was the case of banking of roads. You can see here n sine theta is coming. So you can see here n sine theta is coming to help you. So normal reaction is providing a component. Similarly, friction will also be providing a component. So these two things are now going to help you. So my dear, likewise, you have seen the globe of death in the circus and all. You must have seen that, and you see the bikers are revolving with a very high speed. When they are revolving in this circular paths with very high speed, Fc is equals to m omega square r or mv square upon r. So they also require, my dear, very big value of centripetal acceleration. And my dear, if you are turning on a road with the same speed, accident is must, because friction cannot provide you that much centripetal force. So my dear, when you are making the shape of this globe, this globe of death like that, it is said to be globe of death, it is said to be death well, but actually it is the globe of life, I will say. Because my dear, when you would be giving that much, when you will be giving that much kind of curvature, so let us say if here your biker or car person is there, then my dear, you know, there would be a normal reaction, and normal reaction would be providing a component, because you can feel that if a person is running his car in this circle, then my dear, towards the center one component would be coming from this normal reaction and other component would be coming because of the friction. So my dear, once again, friction and normal reaction both will be providing you the component which will be helping to give you the centripetal force. So a good physicist, a good physics person can understand that this is not going to be a death well, or it is not going to be a globe of death, it should be a globe of life. Because my dear, if you would be running with half of the speed which bikers are running into this, my dear, on the normal plain road, you will definitely met the death or an accident. So this is how physics is going to help us. So guys, now we would be talking about centrifugal forces. We have seen centripetal force with a number of examples. When we are talking about centrifugal force, many students have misconception. They feel when a body is in circular motion, it is subjected to both centripetal and centrifugal forces. Both are equal and opposite and they balance each other and body is in equilibrium. It is totally wrong concept. It is a misconception. My dear, actually, when we are talking about a body to be in circular motion, it is required that it should be subjected to some centripetal force. So if some of the applied forces would be acting like centripetal force or will be providing centripetal force, then only the body would come in the circular motion. So centripetal force we have already seen. Now when we are talking about centrifugal force, it is, my dear, said to be a pseudo force. Pseudo means imaginary force, which we are using only under some standard condition, only under some specific condition, when we are going with the non-inertial frames of references. So my dear, when we are talking about this, many students are getting confused, so we will be going into that, don't worry. So centrifugal force acts away from the center, just opposite to the centripetal forces, but they are the pseudo force. Let us see what is pseudo force from the lift problem. So my dear, in lift problem, you have seen many times in your 11th class that you were having an issue when lift is accelerating with an acceleration of A. There is a mass which is there inside the lift. A person is also standing there. So my dear, when the person is standing inside the lift, lift is accelerating. This is said to be non-inertial frame of reference. So my dear, inertial frame of reference, we are taking Earth as inertial frame of reference, where we assume Earth to be at rest. Okay, yes, Earth is not at rest but revolving with a very slow speed, so we can consider it to be almost at rest. So any other body which is accelerating, it is said to be non-inertial frame of reference. So my dear, in case of non-inertial frame of reference, this person which is inside the lift, he would be able to see something different. According to him, if he will try to make free body diagram of this mass, he would be saying mg is acting up downward, tension is acting upward, and body is moving with an acceleration of a no. My dear, that person will not be able to see this acceleration, because any person can see only the relative things. This acceleration is there with that person also, so he cannot see this. So according to this person, T is going to be equals to mg. And my dear, if a person would be looking the same condition from outside, according to him, he will be saying that T minus mg is equals to ma, because he know the body is accelerating in upward direction. So he will be saying T is equals to m into g plus a. You can see the difference in answer, and you can see as this person is on inertial frame of reference, so the answer of this person would be acceptable. So my dear, we want this kind of situation also to be resolved. So in this kind of situation, if we want to resolve, if we want to make FBD from non-inertial frame of reference, so we need to consider a pseudo force. So my dear, we are going to introduce a pseudo force which is equals to the mass of the body for which you are going to make FBD into acceleration of observer. Observer is inside the lift, so its acceleration is same as a. So pseudo force would be m into a only. So my dear, this force would be assumed onto the block, onto the body, in opposite direction to that of the motion of the lift. So my dear, if this is m, we will be assuming yes, tension is there. So here mg is there. As the body was moving in upward direction with acceleration, we will assume this is pseudo force to be acting downward on the body. So you would be writing the same equation now what this person was writing. So this is how we use the pseudo force concept when we are in non-inertial frame of references. So my dear, same is the case with this. When a car is in circular motion, then definitely it is subjected to a centripetal force in reality. So when it is subjected to centripetal force in reality, it is obviously having an acceleration towards the center. So it means it is in non-inertial frame of reference. So if you want to make the free body diagram of this body as an observer sitting on this car, then my dear, as you are sitting on this car, you are in the non-inertial frame of reference. So what you will be saying, according to you, my dear, if you are sitting in a car, if you want to work over it, you know that when body is in circular motion, then my dear, there would be a centripetal acceleration present, then only body is in circular motion, you know that. But my dear, as you are in non-inertial frame of reference, so to make the free body diagram, you need to consider a pseudo force for sure. And my dear, when you would be taking that pseudo force is said to be centrifugal force, because body is accelerating towards the center. So pseudo force will be coming away from the center, which is said to be centrifugal force. My dear, always mind it, when you are considering centrifugal force, then centripetal force will not be there, because centrifugal is coming because you are going for non-inertial frame of reference analysis. So now if I show you all the cases once again what we have seen, in the first case, if you're talking about, we were talking about the simple pendulum case. So my dear, when we are talking about the simple pendulum case, you know that there is this is the tension acting like this. You know the tension is acting like this. Tension is acting like this. So my dear, you would be applying a pseudo force which is going to be, yes, away from the center like this, and this would be equals to mass of this body, acceleration of the observer, which is nothing but centripetal acceleration, because body is in the circular motion. So my dear, now by equilibrium you would be saying T is equals to m into AC. So my dear, it is just like whether you are going to take centripetal or centrifugal, the answer are going to be same only. These are just two types of analysis. When you are going for absolute motion, or you can say inertial frame of reference, you would be considering centripetal force. When you are talking about non-inertial frame of reference, you would be talking about centrifugal force. So this is the only difference. I would be giving you one more example, like if you are going to see this earth and sun system, Then my dear, you know, if this is sun, this is earth. So you know, if it is in circular motion, it means when it is in circular motion, it simply means that there is a centripetal acceleration actually is there. So as you are doing the analysis from the non-inertial frame of reference, you will apply the pseudo force, which is equals to mass of the body and acceleration of the observer, and this is nothing but the centrifugal force. It is m r omega square, and you know there is a gravitational force acting here. So this gravitational force and centrifugal force would be equal. So guys, this is totally based on you, how you are going to take it. If you are going from inertial frame of reference, you will be talking about centripetal acceleration, centripetal force. Non-inertial frame of reference, centrifugal force. But my dear, centrifugal is nothing but a pseudo force. Centripetal is the real one. So this is the difference between them. So guys, this type of capsule, if you want again and again for different topics, you can mention those topics in the comment section. If you feel any difficulty in some particular concept, these concept capsules are there to make your health proper technically. So goodbye guys.